Welcome to another podcast. In this episode, we're going to be taking a look at what's called the statistical process. Now, I know when you commonly hear the word statistics, you oftentimes think calculations like mean, median, mode. All of these calculations, while a part of statistics, only really constitute a small fraction of the entire discipline that is statistics. In fact, statistics is everything from the data collection all the way to the interpretation of the results at the very end. So it's a very vast and far-reaching discipline, and I want to talk a little bit about the process that you go through that's called the statistical process. So the very first thing that we need to look at here is how to begin, and we begin by looking at what is called data collection. Now, data collection consists of basically what is your sampling method? What is your design of the experiment you're going to do? How do you verify that your data is correct? Are there any outliers in the data? These are things that we'll talk about a little bit later. A good data collection process is the most important part of the statistical process, because if you have bad data coming in, you'll have bad results coming out. The second thing here is, okay, I have the data. How do I visualize it? And so the second step in the statistical process is data visualization. And in this first lesson, we're going to be looking at steps 1 and 2. Data visualization is basically what goes on in Excel, right? If you think about it, you've got your tables, you've got your graphs, we've got things like stem plots, histograms, bar graphs, line graphs, pie charts. All of these have a place, and they have a meaning that's associated with certain types of data. Some work better for some data sets than others. And we'll talk a little bit about some of those things in this first lesson. The third part, and this is what most people call statistics, is the actual statistical analysis. And this is things like looking at the quantitative properties of a data set, things like measuring where the center of the data is, that's mean, median, mode. How spread out the data is, that's things like standard deviation and range, and then maybe how it stacks up against other data sets of similar elements. It's called measures of relative standing. That's things like normal distributions and z-scores. We will talk about all of those things in this unit. Statistical analysis, though, is only a part of the entire process. It's not everything. All right, sort of the fourth step here is a step called regression. And you can think of regression as basically trending. So you can look at trends in the data. Basically, all regression is it's an attempt to try to study a causal relationship between the two variables. So this is what's called bivariate. So this step only occurs if you're looking at bivariate data, meaning you have two variables you want to consider, suppose height and weight. All right, and then the fifth step of the statistical process is the step that is not in this course, but it is in a more advanced statistics course, and that is something called hypothesis testing. So hypothesis testing is an analysis that seeks to determine if the results you get from a random experiment are statistically significant. In other words, with the example that I looked at in the other video of the doctor with with 1,000,000 readings, and then the crew came in and looked at 148 readings to try to dispute the 98.6 degrees. Hypothesis testing can allow us to say whether or not the 98.2 degrees that the other group came up with, whether that's statistically significant enough to be able to disprove the doctor's hypothesis that the average human temperature is 98.6 degrees. So that's a more advanced technique. That's something you would have in an upper level course. But we're going to consider all of 1 through 4 in this class. And so we're going to be looking at 1 through 4 together. Now, associated with this is the idea of a variable, and you saw me talk about bivariate just a second there where we were looking at the idea of regression. So there's definitely the idea of variables here, but these aren't the variables that you're used to I talked about this in another video where we looked at discrete random variables or continuous random variables, but statistics studies something called a random variable. And a random variable is a variable whose outcome is unknown prior to the beginning of some experiment. So the experiment might be to take a person's temperature. The random variable will measure the temperature, but we don't know prior to administering the test whether or not that person's going to have a specific temperature. Now, because it's a variable, there are different types of variables and different type of statistics that we can run on those variables. And so I kind of want to give you a breakdown of all the things that are involved. When we talk about variables, so if I start with a statistical variable, there are two different types. There are what are called qualitative variables. These are things like descriptions, feelings, etc. So a qualitative variable might be take everyone in our class and we're going to record all their eye colors. And so that is a description of the people that are in that sample, but it's not a number description. It's a word description. You could take a psychology test where it asks you to list how you're feeling that day, and the answer choices might be happy, sad, whatever, but that description is qualitative. There is room for qualitative variables, but this is a quantitative reasoning class, and so we're going to be spending most of our time looking at quantitative variables. And among quantitative variables, there are two different types. There are continuous quantitative variables, or continuous random variables is usually what we'll call them. And what a continuous random variable measures is it measures basically readings on an interval. So an example of continuous would be those temperature readings. Because for humans, we might get anything from, 94 degrees all the way up to, let's say, 100 degrees. Any of those wouldn't really surprise you if you were taking a temperature, and that's a continuous spectrum of temperatures that you could possibly get. Now, we might want to increase the interval or lower the interval, but the point is it's an interval. So the readings occur on an interval of some numeric value. The other type of quantitative variable is what's called a discrete random variable. And so a discrete random variable is the readings come from a set, and the set is not infinite, of values. It comes from a set of values. So an example of discrete might be, so maybe you're doing a taste test and you're asked to rate the quality of the food on a scale of 1 to 10. Then, generally speaking, you can only select numbers from the set 1, 2, 3, all the way up to 10. And what makes this set discrete is that it doesn't consist of an interval. It consists of basically counting numbers. That's what we would typically call these. And so if you're looking at a variable that can be described in terms of counting numbers, in other words, this is the first thing you could answer, this is the second thing, this is the third thing, and that's not an infinite set. In other words, you can describe everything, you can label everything as number 1, number 2, number 3, and so on. Then that forms a discrete set, and that forms a discrete quantitative variable or discrete random variable. And so we're going to be looking at many different types of statistical variables. Each one of these lends themselves to a different type of visualization. Continuous random variables lend themselves to a study of things called distributions. And so we're going to look at sort of a general theory of distributions and a specific theory relating to something called the normal distribution. Discrete random variables lend themselves to distributions as well, but they are often limited to what are called frequency distributions. And so we're going to look at frequency distributions as opposed to normal distributions for some types of continuous variables. And so we're going to talk about distributions a lot, and associated with them are the types of variables that we're going to be looking at. And so when I talk about a variable, it's not like an x or a y or anything like that. It's a variable that represents a data point, and that data point could be a lot of different things. So I wanted you to be familiar with some of the terminology so that when I use it in class, you're not confused. This is not normal terminology or not everyday terminology, so this idea of continuous and discrete, qualitative, quantitative, these are probably new terms for you associated with statistics at least. And so I just wanted to make sure that we had gone over those together. All right, thank you for watching.